Hello there, children. Today we are going to work on some factoring techniques. The first one, factoring with the greatest common factors. Now, just so we're aware, the greatest common factor, it is also called a GCF. Now, for those of you in here, you need to realize it is the first thing you try in factoring at all times. So that's why we're going over it first, clearly. So whenever we do factoring, you need to make sure that you attempt to see if the problem has a GCF. But what is a GCF, Mr. Faust? Well, let's go through an example. Okay, so what does it mean? It is the greatest number that we can pull from a group of numbers. So if we have a string of things and I say find the GCF is the greatest number that we can pull from all of them, i.e., it is the biggest number that they all have in common as a common factor. This is really big here. The biggest number they all have as a common factor. So, let's take, for example, just a numerical example here. So, 20 and 25. Find the GCF. So if I do the factors of 20, now I don't expect you to do this every time. 1 and 20, 2 and 10, 4 and 5. The factors of 25, 1 and 25, and 5. Okay. Well, what is the biggest number they all have in common? Well, they have 1 in common, but they will always have 1 in common. But if I look, the next biggest number they have is 5. So the GCF between 20 and 25 is 5. It is a number that I can pull out of both evenly. It is the biggest number they both have in common. It's kind of like if you're asking for everyone for money, or if I'm giving everyone candy. I want to be fair. I don't want to ask someone for something they don't have. Like, sure, this 20 has a 10 in it, but this one can't factor with a 10 in it. So the biggest number that they both have in common is 5. Now, what happens if there are variables? Well, we try to remove a variable that they both have in common. Now, we'll go through what this looks like in practice. So what if I have this? Find the GCF of the following: 7x squared and 21x. Alright, so numerically here, if I go through 21, its factors are 1 and 21, and 3 and 7. The factors of 7 are 1 and 7. So I can clearly see that the biggest number both of these have in common is 7. So already my GCF is going to have a 7 in it. The question is, what about x and x squared? What do they have? Well, what is the same variable they both have? Well, they're both x's. This is a squared, that's an x. What's the power of this x? Well, 1. Thank you. Imaginary voice in my head. So if I have a 1 here and a 2 here, what is the biggest x, or the most x's I can ask these problems for? And the answer is 1, because even though this x has 2, this only can borrow 1. So the GCF is 7x. Now, let's go through another example of this. Now, what do you say we ramp up the difficulty here a little bit? Oh my. So, let's go through this a little bit. Alright, let's look at these constant terms here. I have an 18 and a 24. What is the number that they have? What is their greatest common factor? Or their greatest common divisor, if you want to think of it that way. What is the biggest number that will divide into both of them equally? Let me think about that for a second. Well, it's 6. Now, if I do the factors here of 24, I get 1, 24, 2, 12, 3, 8, 4, and 6. And 18 has 1 and 18, 2, 9, 3, 6. The biggest number between those is 6. Even though technically speaking they both have a 1, a 2, a 3, The biggest number is 6. Now, you shouldn't be doing this every time. Now, let's look at the x's here. I have an x squared and x to the 5th. What is the biggest x that I can pull out of both of these terms? I have 2 x's over here and 5 x's over here. The answer is x and a 3. Now, I look at the y's. I have a y to the 5th, y to the 3rd. The biggest y I could pull out of both of them safely is a y to the 3rd, because even though that's a 5, that's a 3. The most I can ask out of both of them is 3. Now the z's. I have a z to the 3rd and a z to the 9th. The biggest one out of both of them is z to the 3rd. Okay, that's all well and good, but where are we going with all of this? Okay, so let's look here. Now let's apply it to factoring. Factor the following. Wow. Since the first thing I should always try in factoring is what? GCF! Very good, children. So, let's go here and try this. What is the GCF between these two numbers? Well, we've already figured that out, that it's 7x from earlier. Now the question is, I'm going to have to pull out the 7x, but that's just not the final answer. I need to do a parenthesis here, because when you pull out a GCF from a problem, unlike the previous ones, when you say factor an expression, you're going to have to write what you have left over. So the question you need to ask yourself is, what times 7x gets you 7x squared? The answer is x. Then you go, what times 7x gets me 21x? Well, what times 7 gets me 21? 3. What times x gets me x? Oh, that's no big deal. No x is needed there. So I'm done. Let's try some more of these, shall we? Alright kids, let's try this one here. Now this one is considerably more difficult. Ooh! Let's just let this soak in for a second. Okay, so, how do I do this? Well, considering the only factoring technique we've done so far is GCF, let's find out what the greatest common factor is here. So I look. Again, look at all the constant numbers. 15, 5, and 10. What is the greatest number I can pull out of all those? The answer is 5. It's the biggest number I can pull out evenly. Now, let's look at the x's. I have an x squared, an x, and an x to the 9th. What is the biggest x that all of them have in common? And the answer is x. Now, I know what you're thinking, but there's a square there and a 9 there. But there's a 1 right here. So the biggest one that they all share that I can ask them from each of them is x. Let's look at the y's. I have a y to the 7th, a y to the 3rd. The biggest one is y. Now, let's put and figure out what I need here. What times 5 gets me 15? 3. I have 1x. I need 2 of them. How many more x's do I need in here? An x. I have a y. I wanted 3 y's. How many should I have in here? 2 of them. What times 5 gets me 5? 1. Do you have to write the 1? No, I will here, but you don't have to, no problem. I have an x. I need an x. What more do I need? I don't need to put an x here. I had a y. I need 7 of them. That means I need 6 in here now. Let's figure out. I had 10. I pulled out a 5. So what times 5 gets me 10? 2. I had an x. I need 8 of them in here. Because remember, when you have these powers, you're going to add the exponents, multiply coefficients. I had a y. I have a y out here, so I'm good. Now, if you're not sure you did this right, distribute this back in there to all of them, because sharing is caring. And you should be able to handle it. You have now had enough information to figure this problem out. And this was tough. It really was. So now you can start factoring using GCFs. Go henceforth and do.